So continuing in our topic, thinking and looking at similar triangles, we're going to take a look at what's called the triangle side splitter theorem. And the side splitter theorem just says if I have a line segment that splits two sides of a triangle proportionally, I think that's the key word there, and it's going to say if and only if it's parallel to the third side. So what that means is if I have a segment and I know it's parallel, it will split the two sides proportionally, and vice versa. If I know I have a side that splits two segments proportionally, well then it must be parallel. So looking at this in practice, it's asking us for number one, to find the value of TS. So I'm going to label that X. I don't know what that is. If I know that TU is 5, and I know UV is 10, and we know SR is 16, and we know our lines are parallel. So in this question, by having them state to us that those lines are parallel, I can use the side splitter theorem, which means the parts of those sides are going to be in proportion. So we can set up a couple of different proportions. One would be to take a look at one full side, for instance, let's say the left side, and compare those two. So let's say maybe top compared to bottom. I could then set that equal to the right side, keeping that same proportion and thinking top compared to bottom. Now, when we have proportions, we can think to ourselves, in order to solve this, we want to cross multiply. So if we cross multiply, I would have 10x on one side. On the other, 16 times 5, we're going to get a total of 80. And then dividing through by 10, we're going to find x is equal to 8. Okay. Another example we have is, again, we have lines that are parallel. So as soon as I see that, I can think, okay, so I know this is splitting my triangle, the sides AB and CB into proportion. And it says if BX is 9 and BA is 15, so notice what they're giving us here. They're giving us this entire side. It says BY is 15. What is YC? Okay, so we could actually solve this problem in two ways. If we're using our side splitter theorem, keep in mind it's telling us that it's splitting the segments into proportion, meaning I would need the parts. I need to know the length from B to A, and I would need to know the length from A to X, which we can find. If I know our whole side's 15, and I know the part they gave us is 9, subtracting those out, that's going to give me our parts. So now this problem looks just like it did up in number 1. So making our proportions, maybe comparing top to bottom on the left side, top to bottom on the right side, and at times it might be a good idea to kind of write this proportion out so you keep in mind, what am I comparing, how am I setting up my proportion. So I'm thinking top compared to bottom is equal to top compared to bottom. Okay, and like we did up above, we're going to cross multiply. So we have 9x is equal to 6 times 15, which is 90. And if we solve for x, we're going to find x is equal to 10. Now that's using that side splitter theorem. A different way we could do this is we could say, well, these two triangles must be similar. And the two triangles I'm looking at, just so we are aware, would be, let's say, for instance, this top triangle BXY, and then the big triangle BCA. And the reason I know they're similar from our last unit, if I have these lines that are parallel, I could prove these angles are congruent because they're corresponding. Same thing on this side, I could prove these angles congruent because they're corresponding. We also have that reflexive angle up at the top. So I have plenty to prove those triangles are similar by angle. Since I know the triangles are similar, I know the sides are in proportion, the entire side. So kind of like they gave us the whole side of that red triangle is 15. So if I'm thinking a proportion I could set up on this one, it might be the left side. I could think all the left side small triangle to big triangle. So maybe my proportion here is small compared to big. So on the left side of the triangle, I would have 9 over 15. And on the right side of the triangle, I would have my small side is 15. Now be careful, we need the whole big side, which I would get by adding. So then we could solve just like we did before, cross multiply. So 15 times 15, I get 225. And now don't forget, you have to distribute here. Okay, so when you distribute, 9 times 15, we're going to get 135. 9 times x, you're going to have 9x. And if I subtract the 135 over, I have 90 equals 9x, just like we did on the other side. And I'm going to still find x is 10. So here's two very different ways that we could solve this problem. First method is dealing with that side splitter theorem. Second method is dealing really more with similar triangles and being in proportion. Okay, moving on, taking a look at number 3, now a little different. It says, so what conclusions could we make from this diagram on the right? Okay, well, if I'm thinking maybe they're proportional, maybe my triangles are similar, I'd want to test it. So what we did up above is we had made proportions. Again, we kind of did top to bottom. So I'm going to do that same thing. I'm going to compare the top side to the bottom. Then on the right-hand side, I'm going to compare the top to the bottom. And what we're really doing here is we're saying, are those in proportion? So if I cross multiply this, so 1.5 times 6, I'm going to get a total of 9. 2 times 4.5, I get a total of 9. So that's showing me, okay, sides are in proportion. What am I able to say from this? Well, sides are only in proportion if these two lines here are parallel. So I could then tell you, okay, so VW must be parallel to XY. So if those are parallel, what else is that going to tell me? Well, I get a bunch of angles. So I would get angle UVW is congruent to angle X. Because why? Well, those are corresponding angles. And I know my corresponding angles are going to be congruent when my lines are parallel. Similarly, I could do the same on the other side. So angle UWV is congruent to angle Y for the same reason. Okay, well, we have two angle sets that are congruent, so now think about what that's also going to tell you. Conclusion, triangle UVW is similar to triangle UXY. So we've been able to say a whole bunch by just knowing that that line is parallel, sides are in proportion, or I should say parts are in proportion. That's going to tell us our triangles are similar. Okay, extending this theorem, a corollary, kind of an extension of what we've just done, is that when we have 3 lines parallel, so we only looked at 2 lines being parallel, now if I have 3 lines parallel, I'm also going to see that the segments that they intercept are also proportional. So by looking at this, it's almost like a Faker triangle. If I extended this out, kind of looks like a triangle, and it's still saying, well, then these parts are still going to be in proportion. So just like we did on the front of the page, I can set up a proportion, keeping them consistent. And if we cross multiply, I get 12x is equal to 72. And dividing through, I'm going to find x is 4. So nothing really changes. It just gives us an extension that says I can have more than one set of lines that are parallel. So in this case, I have 3. Okay. Similarly, down here on number 5, so I have 3 sets of lines that are parallel. And if I'm going to label this here, I have AB is 7, I have CD is 4, I have FD is 6, and then I get this ratio. AE to EC is 1 to 4. Okay, so anytime we see a ratio, I always think attach a variable. So it's like saying 1x to 4x. And then it says if the perimeter of that entire trapezoid, so all of the sides added up on the outside edge, are equal to 31, we have to figure out what these 2 segment values are. But the problem is I don't know what BF is right now. So keeping in mind that these 2 sides are in that 1 to 4 ratio, okay, I could say, well, if AE is 1 and EC is 4, then that should be the same ratio as, I'll call BFY, since that's what we're looking for, BF compared to FD. And I can make this ratio because I know all of these lines here are parallel. So what that's telling me is, again, those segment parts will be in proportion. Okay, so cross multiply. I get 6 equals to 4y. And so y equals 1.5. Don't be worried about a decimal. Decimals are numbers too. So over here, I have this length is 1.5. Okay, so now I could go back and use that concept of the perimeter. If I added everything up, so if I did x plus 4x plus 4 plus 6 plus 1.5 plus 7, that should total 31. Okay, so if we combine our like terms, I have 5 total x's. I have 18.5 for constants. And now I just need to solve for x. So subtract that 18.5 over, and we get a total of 12.5. And if I divide through by 5, I'm going to find x is 2.5. So what that has found then is that length AE, because AE was valued at x. And if I multiply that by 4, we're going to find EC is 10. And we have just found our missing sides. And again, I could compare these because they should be in that 1:4 ratio. And if I look at that, 2.5 times 4 would give me 10. Okay, and then lastly, if I'm looking at this maybe in terms of a real-world application. So it says at a certain time of day, a 12-meter flagpole casts an 8-meter shadow. First, we're going to write an equation that would allow us to find the height of the tree. It uses the length S of the shadow. So now, notice we have 2 variables right now. We're not really going to be solving just yet, but I should be able to make a proportion. And again, we said as long as our parts are consistent, I should be able to set up some proportions here. And go back to that concept of they have to be parallel. Well, hopefully our tree is vertical and the flagpole is vertical, so 2 vertical lines would be parallel. So keeping that idea, if these are parallel, my sides would be in proportion. But now think about this. Am I really using the side splitter theorem here, or am I just using proportional triangles? It's kind of more proportional triangles if these lines are parallel. Again, what are we going to have? We're going to have corresponding angles that are congruent. So I could prove to you the 2 triangles. Okay, so we have a big triangle with the tree and the shadow. And then we have a little triangle with the flagpole. These guys have to be similar, so I know our sides are in proportion. Okay, so setting up some proportions here, I could maybe take my little triangle and say 12 compared to 8. So flagpole compared to the shadow is equal to the height of the tree compared to the shadow of the tree. And we could solve something for this if we had some numbers. So let's say, for instance, let S, our shadow, equal 20 meters. Okay, so if we plug that in, I would have 12 over 8 is equal to H over 20. And again, I can cross multiply. So I'm going to have 8H is equal to 240. And if we solve, now I can find the height of that tree is equal to 30 meters. So that's a little bit more with some similar triangles, setting up some proportions. We're going to practice some more and do some more applications in class. Don't forget, like and subscribe. Hope this helped. Have a great day, everyone.